Hello my dear students, today we will speak about the main properties, general properties, physical and chemical properties in general of the first series of the main transition elements. These elements starts with scandium 21 and ends in zinc 30. So there are some main points that we have to take into consideration and to understand well as we going to explain the general properties of the first transition series elements. Okay, so the first idea that we want to discuss with each other is the concept of metallic bond. So what is metallic bond? Metallic bond, we know all the metal structures like iron metal structure or like copper metal structure, they are formed of positive ions arranged together in a compact rows. So these compact rows compacted together, arranged together, positive ions, and they are surrounded by valence electrons. The positive ions is positively charged and the valence electrons is negatively charged. So if we look at this shape, so we see that metal positive ions surrounded, which is positive, surrounded by negative electrons. These negative electrons make to bind the or decrease the repulsion force between these positive ions. So the collection of these positive ions and the negative electrons inside this crystal lattice of any metal is called metallic bond. So the metallic bond is the electron cloud, the valence electron clouds, which decrease the repulsion force between the positive metal ions in the crystal lattice. So positive metal ions, like the building bricks, and here the binding between these positive ions is like the cement, which binds the positive ions with each other. So as the cement or the valence electrons increases, so the strength of the metallic bond increases. So here this is a metal with 3 electrons and metals with 2 electrons in the outermost shell, and as the number of electrons increases in the outermost shell, or the valence electrons I mean, then the strength of the bond of the metallic bond increases, so the metal itself becomes very hard. So this is 1 valence electron, so its hardness is little. Here 2 electrons as a valence electrons, so the binding force between the positive ions here is more, and it is more harder here when the valence electrons are 3. Here is more electrons used to decrease the repulsion force between these positive ions. So the metallic bond is the collection between the positive ions in the metal structure and the valence electrons, negative valence electrons, which form a cloud binds these positive ions. So let's go to another idea. Exothermic and endothermic reaction. Exothermic and endothermic reaction. Exo means go out from the system or from the reaction container. Endothermic means energy go from outside the container of the reaction to inside the container of the reaction. So here exothermic reactions. What is exothermic reaction? Here reactions, here this is heat content, the y-axis, and the direction of the reaction, the x-axis. Reactants here, and as the time go, reactants react together to form a product. But here we notice that the level of the heat content decreases, so energy goes from the system out, so the system container or the system as the product and the reactants, its energy decreases from this level to this level. So the change in the overall heat content with negative sign, as the heat content of the whole reaction decreases by this amount. So delta H here has a negative sign, less than 0, as the product heat content is less than the reactant heat content. Here it is endothermic reaction, where the reaction takes some energy and the heat content of the product is higher. So delta H here is positive sign, and delta H or the standard heat content of the reaction higher than 0, as the reactants take some energy and form products with higher heat content. So exothermic means energy decreases and releasing of energy from the reactant to the product. Endothermic means the reactants accepts energy and the energy of the product is higher if the product is higher than the energy of the reactants. Let's have another idea. Atomic mass of element. Atomic mass of element, we can calculate it by calculate the relative isotopes and their percentage. How can we calculate it? Here we have an example. Nickel, its atomic mass is 28, but its atomic number is 28, but atomic mass here, the molar mass of nickel, it changes. As we know that 28 means the number of protons inside the nucleus of nickel atom, and 58 is the summation of number of protons, positive, and the neutral particles, which is neutron. The number of neutrons differ from one isotope to another isotope. In this case, there are 5 isotopes of nickel. All these isotopes have the 28 number of protons, but the number of neutrons differ from one isotope to another. So if we can calculate the average mass of nickel, we can know the exact mass of these 5 isotopes. So the mass of the nickel equals the mass of each isotope multiplied by its percentage. It is the summation of all these. The mass of nickel 58 over the percentage of nickel 58. The mass of the isotope 59.9 multiplied by the percentage 26.1 over 100, and so on. And summation of all these gives 58.7 atomic mass unit. So we want this information to know the nickel, as nickel here its atomic mass may reach 64, but its actual mass, or the average mass of all these isotopes of nickel, equals only 58.7. We have to put it into consideration. So here we will speak about general properties of the first condition series elements. We will speak about the atomic mass. Atomic mass here refers to the number of protons and neutrons in grams, so, or in the atomic mass unit, but here as moles we speak about the grams. We see that scandium, which is 21, its atomic mass is 45, then titanium 47. So the atomic mass increases as we go from left to right. But here there is an exception, which is nickel. Nickel is supposed to be higher in mass than cobalt. Cobalt here 58.9. So nickel here is 58 only 0.7. So nickel here is an exception, abnormal single mass property. Why this decrease in the nickel mass? The decrease is attributed to nickel has 5 stable nickel isotopes with an average of 58.7. Because of this, nickel is an exception in the increase, or in the increment, or the increasing of mass from left to right in the first transition series element. So when you ask it that there is an exception in the atomic mass, the exception is nickel, which has 5 isotopes with average atomic mass 58.7. So when you ask it that, there is some arrangement of elements inside the first transition series, and you ask it which of them is nickel. Which of them is nickel means which of them its atomic mass is less than the element which precedes nickel, which is cobalt. Cobalt here, the average mass 58.9, but here the average mass of nickel is less than cobalt. It is supposed that when we go from left to right, that the atomic mass increases, but here nickel is an exception or abnormal case. So we have to take into consideration, and also when we discuss with each other the electrochemistry, we will memorize that copper, its atomic mass is 63.5. So the element which precedes copper is nickel. So let's speak about another factor or another general properties, which is the atomic radius. The atomic radius here, as we go from left to right, it is supposed to be the attraction force from the nucleus, or the effective nuclear force on the valence electrons increase. So in this case, the nucleus pull to itself the valence electrons. This leads to the reduction of the volume of the atom. So it is supposed that theoretically that scandium is higher than titanium as the effective nuclear charge increases from left to right. So in general, the atomic radius supposed to be decreased. So it decreases as we discuss, as we have said, from scandium to titanium 1.2, 1.32, 1.22 in vanadium. But here, starting from chromium, there is a repulsion force. This chromium, its electron configuration is 4s1 and 3d5. So each orbital in the 3d is filled with half filled with electrons. There is an electron inside each orbital. So the repulsion force between electrons in the orbitals from chromium will be equal, or will neutralize, or will be balanced with the effective nuclear force. The effective nuclear force causes the volume to decrease, and the repulsion between electrons in the orbitals cause the volume to increase. So the increase of the volume because of the repulsion force between the electrons in the d sublevel offsets the increase in attraction force because of the increase in the effective nuclear charge from left to right. In this case, there is a factor which affects the volume of the atom to be decreased, which is the attraction force between the nucleus and the valence electron, and the repulsion force starts from chromium, which is the first element which contain in each d orbital one electron. So we see that the valence is the volume starts from chromium to copper is nearly constant. Because of that, we can make from the transition elements a substitutional alloy. Substitution alloy from its conditions that the volume of the two elements participating in this alloy have the same or nearly the similar volume. Okay, from chromium to copper, the same atomic radius, but we have to put into consideration, because of the questions concerning the exam, that first two, chromium and manganese, and the last one, copper, have the same size, 1.17 for chromium, manganese, and copper 1.17 angstrom. Angstrom is a measuring unit, equals 10 power minus 10 of meter. Okay, so here let's have some examples. The following table shows the atomic masses estimated in atomic mass unit U of 8 of the first transition series elements. So which of them element is nickel? As we have said, this 63.5 is copper. the element which precedes copper is nickel. So if we want to make sure of our answer, if it is correct or not, here we see that cobalt 58.9 and the atomic mass of nickel supposed to be higher, but here 58.7 approximately. So nickel is the only exception. Here the correct answer, the nickel, is the exception of atomic mass, which is when the atomic mass go from left to right, it increases, supposed to be increases, but here nickel is less in atomic mass than the preceding element, which is cobalt. Okay, so the correct answer here is Y, which is C. Let's have another example. So the opposite diagram shows a section of modern periodic table. What are the two elements which have nearly the same size? Okay, here S block and P block, this is the first transition series. Starts with scandium, titanium, vanadium. Starting from chromium to copper, the volume is constant. So he asked about the similarity of the volume of the atom. So starts from chromium, manganese, copper, there are the same volume, starting from chromium to copper, here 29. So chromium and iron have the same volume. So C is the correct one. Okay, at this point we finish our session. Thank you.